Everyone. This session we're doing, I have four CEOs of different biotech companies that have come through IndieBio. And what I actually want to do a little bit different than most panels I think I've done in the past is actually have it be driven by Q&A from the audience. So I'll have questions to throw out the panelists if it's silent. But to start off, I'll just introduce IndieBio, ask each CEO to introduce their company, and then have you guys throw out questions in the chat, which then I'll read and the panelists can answer. So to start, I'm one of the partners at IndieBio. We're a biotech accelerator based in San Francisco and now New York, part of a larger venture fund called SOSV. And a big part of our investment is in planetary health across the board. So in the last 5 years, we've invested in about 125 companies or so. A little over half of those are across food systems, so like cell-based meat, ag tech, growing rice in the ocean, bee pollination, soil microbiome companies, things in biomaterials, so bioplastics, construction tech, replacing steel with plant-based products, a lot of industrial bio, so moving from petrochemical based to biomanufacturing production, and even a few bioenergy companies. So we run in a batch program where we do 4 months with a group of companies that we invest $250,000. So that's a high level about us. And now I'm going to toss it over to each CEO to give a little bit of a background on themselves and their company. So maybe to start, could I get David from Nova Nutrients?
Hi there. Thanks, Alex. I'm David Say. I'm the CEO of Nova Nutrients, and we make food from CO2, which is to say we use hydrogen-based biosynthesis to take energy and CO2 and make ingredients for food and for animal feed. And we were batch 7 in second half of 2018.
Alex from Electroactive.
Yeah, I'm Alex Lewis, CEO of Electroactive Technologies, and we're developing a hybrid biological electrochemical system that can be deployed as a modular system to convert food waste into renewable hydrogen, which we envision as a means of energy storage as well as to power fuel cell applications. And residual solids in the process can be turned into compost or other products to have a kind of circular closed loop system in place.
Cool, thanks. And then can I get Julie from Kepra?
Hi, so I'm Julie. I'm the CEO of Kepra, and we are the sort of ultimate waste to fuel solution. And we tackle 2 big problems, and that's renewable energy storage as well as handling plastics waste. So we take excess renewable energy and we use it to drive cavitation, and that breaks down plastics and agricultural waste into carbon neutral fuels.
And then last up, we have Quincy from Carbx.
Hi, I'm Quincy. I'm the founder of Carbx, and we're turning CO2 into carbonates. And we use these carbonates as raw materials for multiple products across various industry. Nature does the same thing by carbonating CO2 into rock, but it takes hundreds, thousands of years. We do it in a few hours with our advanced reactor technology. Thanks.
Cool. Thanks, guys. I guess while we're waiting for questions to come in, one of the first things I thought would be interesting to start with is one of the big challenges that we saw, like when we're doing investing in a lot of the carbon sequestration spaces is, if you can capture it, what is the end market to go towards? Like, where does it make sense? Where is there need? And where is there an advantage that the technology provides? So I'd be curious to have you guys each share a bit about the target market you're going towards and why you actually found your technology has an advantage over the traditional methods that people are serving that right now. You guys can just chime in one at a time. Anyone? Alex, you want to start?
So yeah, or Alex Lewis, Electroactive Technology. So, we decided to deploy and come into our system because there really wasn't a lot of good options out there to convert food waste because it's so complex. And so we have a technology we think can really deal with that by leveraging a microbial community, which has a lot more robust functional characteristics than highly engineered single organisms. And that gives us kind of an advantage over some of the technologies that are there, as well as other ones trying to use microbial communities like anaerobic digestion, but they require really, really large scales to make it work. But we grow ours as a biofilm, which allows us to really concentrate the productivity in a smaller area and enables us to have a modular system that can really, open up the opportunities for converting food waste. And and the hydrogen we decided to produce from that, we see as a real, growing option for a zero emission fuel, to go along with battery vehicles to find, zero emission transportation that can be affordable, is kind of our perspective on our technology. And
one thing, Alex, and for everyone else, can you add a little bit about what does your system look like? Is it something that is a big, one large manufacturing site, or what does it look like for the end customer as well?
Yeah, we plan to deploy ours somewhat in a box to make it as easy as possible to have this product on a site. And as well, we plan to actually offer our system as a service to another level to take the burden off of customers from having to operate a system. We can kind of plug and play and drop a system at a site where there's food waste and a need for hydrogen, and be able to easily come in there and take any type of food waste or organic waste and have it go into the system and have hydrogen come out the back end. So we're in the early stages of that, but that's kind of our mindset to make it very seamless and easy as possible to deploy these in a variety of locations.
Cool, thanks. Quincy, you want to jump in? See you on my screen.
So what are we talking about real quick?
Just a bit about kind of with the problem with a lot of carbon capture we saw is what is the end market? Where are you sequestering your carbon to provide value for the market?
So yeah, I mean, the conventional wisdom, has been put it in geological storage or buried in undersea cavern or undersea formation. The only thing is, I mean, you can't monetize the product. So, in our case, we make carbonates from CO2. We need to sell those carbonates as raw material. And we can still reach the same goals of long-term storage in, say, cement and concrete, because obviously the cement and concrete becomes roads, becomes bridges, becomes buildings. So we can still achieve that same kind of long-term storage and still monetize and have a revenue base to go to. So I don't think that locking it away completely undersea or in a geological formation, should always be done. We can definitely monetize through product long term.
Thanks, Julie. You want to go next?
Sure. So on a grand scale, what we're doing is we're building an array of solar panels and we're connecting it to an array of reactors. And those reactors basically just fit in where a battery normally would fit in. And so this is all bundled in the same general contract for renewable energy certificates and the units of power and the units of fuel and the carbon offsets. And so you just create this great goodie bag full of benefits to the biggest buyers of renewable energy, which are actually corporations, corporates like Google and Apple and even places like Walmart. And so we were inspired to create our solution because previous biofuel production actually used more fossil fuel than fuel it created. And another big problem was there was this big focus on algae. And it actually took 10 years for them to properly genetically engineer the algae to be in its sort of ideal form for creating fuel. And then the third thing is it just wasn't that efficient. We wanted to completely electrify the process, which is why we used ultrasonics as opposed to temperature and pressure processes. And the other benefit of ultrasonic processes is it's actually a far more effective method of energy transfer. Freeze. Oh.
I think might have lost Julie. David, do you want to go while Julie reconnects?
Yeah, happy to do that. So the question is about essentially why did we choose to apply our technology to the market or markets that we have? And so it's worth, in our case, going back and looking at how our company got started and what the technology platform was originally tasked to do. So our company was actually started operating in 2009 and pretty quickly began using these hydrogen oxidized bacteria to make N-butanol with technology that was in license from the Ohio State University. And PHB biopolymers were another area, and it was only in 2016, 2017 that I came on board and the company pivoted to nutrition, changing the name we do business under from Oak Bio Inc. to Nova Nutrients. And so the reason why we are more interested in nutrition than biofuels, than materials, than pharmaceuticals, even though a generalized biomanufacturing platform like this can support all of those, is because that's where there are some of because there's an intense reliance on natural resources to produce nutrition, to produce food ingredients and foods and food additives. That was an area where essentially a kilo of product had the most value. Whether you're looking at a cat food or a feed for farmed Mediterranean sea bass off of Greece, basically these are animals that need to eat a high value protein like eating fish. Cats eat fish, big fish eat small fish. And so replacing the Peruvian anchovy was essentially the most interesting initial market. And that's one where last year was about 5 million tons of protein production in just that area called fish meal or fish flour, and with a value of about $7 billion. And so that's what we're targeted on taking care of first.
Cool. And first question we got from the crowd is, I think, a really natural place to go. I think a lot of people associate biotech with things that have lower yields, or less efficient, or more costly than thermochemical processes. So it'd be great for each of you guys to talk a bit about how you're approaching scaling and efficiency, and how you see your system being able to outcompete whatever is currently being done in the market to provide the solution, whether it's food, hydrogen, carbonation.
Yeah, so if I can just continue what I was saying and answer this question, from our perspective, we think our platform is good if you're making molecules that have 6 or more carbons, roughly. Fewer than that, and yeah, synthetic chemistry is great. The more complicated the organic molecules that you're trying to make, or the greater variety that you're trying to make at the same time, the more it makes sense to have a biological solution.
And can you just talk a little bit about, David, and for everyone else, what does scaling actually look like for you guys? What is kind of the system you're using, in case people aren't familiar with it?
Right. So, a complete production system is going to start with gas handling. And you can see behind me, gas and input handling. Then it'll go into a bioreactor, which is to say there's an aqueous solution that has various things dissolved in it, including CO2 and hydrogen. That's where the microbes grow and reproduce, and either themselves are the product or excrete the product into the medium. Then you need downstream processing to take that wet slurry that you can harvest and turn it into a usable product. So these are the overall systems that one needs to scale. The upstream and downstream parts around the bioreactor are very well understood. It's a matter of configuring and engineering, not invention. Our innovation is the hardware, the wetware, and to a certain extent the software that takes place, that is the bioreactor and what's happening inside the bioreactor. And so scaling there is primarily a question of volume and productivity. So you want to go from a bench scale, which might be 5 liters of fermenter volume, to lab scale, which for us would get into the hundreds or potentially 1,000 liters. We have 55 liters right now, multiple 55-liter reactors. And then once you get out in the field, pilot scale, 1,000 liters or more, demo scale, 20,000 liters, and commercial scale, for certain markets like bulk protein, where you're not taken seriously unless you're making more than 10,000 tons a year of product, need to be roughly 500,000 liters. We think that the ultimate commercial projects, which may be, will obviously have multiple fermenters operating in parallel, would be millions of liters. So that's how we think about it. It's relatively capital intensive compared to other Silicon Valley businesses, and so as much effort as we put into our technology development, business development is very important because essentially you have to find other people who are willing to pay for this scale up.
Well, thanks, David. Alex, do you want to jump in on that? Talking about efficiencies and scaling for you guys?
Yeah, definitely. That's a good question. Around biological routes being, lower yielding or less efficient, but for us, in my opinion, the biological routes can actually be really, really efficient. The main problem I see is that the reaction rates can be a little bit more limiting and take a longer period of time to make X amount of product compared to other synthetic or thermochemical routes. And so those, thermochemical routes can have some advantages, but they have a lot of hurdles, really high capital costs, really huge scales to be economical. So depending on the application, that could be advantageous, but for what we're pursuing, we see a more distributed approach where you can be on site, being more advantageous that with our biological electrochemical system that we have. And so we're kind of pairing two very efficient reaction mechanisms in electrochemical reactions and biological reactions. And going in a distributed way, we think is advantageous in the food waste space where that's produced in a distributed way. And compared to thermochemical routes as well, moisture can be a big challenge for those type of systems. And food waste is around 80% water. So that can be a problem for that feedstock stream for that kind of route. Related to scaling, biological routes definitely can face challenges scaling up. Microbes can get unhappy when you start to get larger and larger there. And so we're dealing with that a little differently with taking kind of a stack approach and utilizing biofilms to get high performance in a smaller amount of volume. And then the stack approach will allow us to have these kind of smaller reactor units where we don't need to scale up to hundreds to thousands of liters or gallons. We actually just have much, much smaller units that can then be replicated and have thousands of cells stacked together to de-risk that scale-up process. And it can be made economical. And that you might think that, that approach can have a lot more materials involved. But we use very low-cost materials to be able to make that possible.
Yeah, Alex, I think maybe just diving into like what is the size of a first unit, because I think people tend to think of biomanufacturing at million-liter scales, and the fact that we do little replicates of cells.
And for us, like some of the scalings we're targeting, I guess, is based on the end use of hydrogen, where for some of the fuel cell applications, it wouldn't make sense we can make it as small as possible. We're like one for the home, but we're anticipating our first units being, the size of I guess around the size of a shipping container or even smaller than that, where it'd be, let's see, maybe like 10 meters cubed in size. And then that, kind of box unit could be, dropped at the sites for hydrogen use or where the food waste is kind of what we're envisioning. But being able to scale that down or up depending on the application. And if they have a use for hydrogen at smaller scales, we're planning our pilots for early next year. We'll be demonstrating like a meter cubed modular unit to produce a few kilograms of hydrogen per day, and then we can replicate those units for larger commercial systems.
Well, thanks. And Quincy, when I'm talking about your system, you have two comparisons. One, you're showing you can do the typical weathering process that takes hundreds of thousands of years in a very short amount of time. So you kind of have that proof point, but also showing you're competing with normal non-carbonate concrete or other things. So maybe talking about how you compare with those two things could be interesting.
Yeah, the competition now, it's straightforward. It's fairly carbon intensive process to make cement and concrete. I think as a matter of fact, it's about 10% of our emissions do come from cement and concrete industries. So we are completely doing the opposite of that. We're using CO2 as our feedstock to create the cement filler, which is a type of magnesium carbonate. It could also be a calcium carbonate. And this product is coming out carbon negative. So we're able to not only capture or eat our own trail of emissions and bringing the minerals to carbonate, but also our own processes as well. So in terms of, as we scale, we're looking at other different ways to scale too, so that we can reach larger markets with more cement production. We're looking at the choices that Alex just mentioned. Do we go one big reactor? Do we do a series of small reactors? And we're probably leaning towards a series of a small reactor size. But throughout this whole process, and unlike the current cement and concrete production, it's a carbon-intensive process. Our process is carbon negative.
Can you mention a little bit about your goals for speed of production?
So in terms of where we are right now, in terms of speed, a lot of the magic is going to happen in our reactor in our use of light energy. So we're using a different approach than what's come before. We're still using some basic heat, pressure, a lot of RPM, but we're introducing photolysis, and specifically we're working with a kind of an obscure range of light band called UVC. And what this does, this dissociates magnesium and increases our precipitation rate. So the faster that we can get CO2 to bind as a carbonate, the faster we can get a product out, and obviously the faster the market we win is we want to win that race. And the reason for all of that is that the faster that we get CO2 out, the better off humanity will be.
And then Julie, I think I see you're back now. In case you missed the question, it was around efficiency and yield and scale for the company. So do you want to talk a bit about how you see the technology being able to scale in a way that makes it actually like cost competitive and able to go to market? You're on mute right now.
Sorry, is that better?
Yep.
Okay. Right. So going to market, there's sort of a few things that are very important to consider since it's sort of like a very diverse marketplace where there are batteries on one end. We have to convince our partners in solar that we're actually better than batteries. And the way that we do that was you go after these really large scale projects up to hundreds of megawatts, because that's where batteries tend to fail. And then on the other end, we also have to outcompete on price with petroleum and natural gas, just because it's a commodities market. And so you really can't, you don't really pay a green tax on these things. People will just go with the cheaper option. And biofuel has had a lot of problems with this in the past. We started at $10 per gallon of basically green gasoline, and it got down to about $5 by the time the bubble popped, which can just be improved through developing the technology, and we're sort of in a similar spot. But the way that we're going to scale is we're using feedstocks which are next to zero cost, or we can get paid to offload. One of the big things that we're looking at is ocean plastic, and at plastics which cannot typically be recycled, specifically various forms of polypropylene. Polystyrene is often not recycled as well. And so by using a diverse range of feedstocks that are very cheap, we're keeping our operational costs low, and that will help us compete with petroleum.
And then as maybe wait for more questions coming from the audience, for those of you who had time and a lot of interactions with the market, how are you seeing uptake coming in from either end, either the waste that's coming into your system or from the people who are buying the end product? Are you seeing a lot of traction or interest?
I'm happy to address that, Alex. So there are, a lot of people with carbon emissions who would prefer that not go into the atmosphere. So that has not been an issue. The issue is really the availability of low-cost energy, particularly in the form of hydrogen. So the difficulty, I would say, in interacting with markets, we really have two markets. There's our own market for inputs. Hydrogen is the primary concern there, and then there's the market for outputs. The limiting factor in terms of our interactions with our customer side is the request to provide large volumes of samples. It's very common for folks in this in feed ingredients to want hundreds of kilos, tons of material to do an evaluation. And so we have to put a lot of effort into finding folks who are willing to start working with us on the basis of the smaller quantities of material that we have available today.
Oh, I can jump in after David there. Similar things, I think, on just to talk about that party at the end there as well. Getting to the right scale, people want to work with you there. Where us producing hydrogen as well, which potentially could be a feed for David's company in the future. We're working to get our costs down, but to get to the scales to produce hydrogen that people will want to use or work with on a project is something definitely that they are wanting much larger quantities of hydrogen. So we're working to rapidly scale to get to that kind of point. But at least what we're hearing from potential customers and partners like fuel cell manufacturers is, people are not happy, as David has kind of alluded to as well, with the hydrogen supply market. It's not where it needs to be, and it's not low cost enough as well. And we think we have a pathway to get there. Also, using waste feedstocks to get to zero or potentially negative cost feedstock is one way we can get there in the near term. And so that input of food waste is continuing to grow, and the legislation that's coming out in different states as well is continuing to add drivers is going to continue to push food waste towards new pathways outside the landfill as more states and regulations come out preventing food waste and other organic waste from going to landfills. There's starting to be a buildup of where can this food waste go, and there's not a lot of good solutions out there. But luckily, some of the other companies, in addition to ours, are really trying to solve that problem and use that input to make a useful end product that can be renewable and sustainable.
And Julie, Quincy, anything to share on your end?
So in terms of customer development, I actually just had a chat with one yesterday. So in bringing the prospect up of using carbonates in their product, which happens to be quartz type countertops and other types of materials that the carbonates we're developing would work in. They are sensitive to commodities and the pricing. So, but look, so I told them, hey, we're using CO2 to make this. It's less carbon intensive. It's environmentally friendly. It's like, yeah, I get it, but I pay X amount for this, and then I pay X amount for that, and then I pay 100 plus a square foot retail. So going through all the price schedule, I think that working in a commodity field, we're still going to get hit with some very tried and true. It's a commodity. I pay X. Okay, yours is carbon negative. This one might be a little cheaper. So I think that the way around that is maybe flatline with other suppliers. Even if we have a little bit more costs, but we also need to be creative when we work on the revenue side, on the distribution side, where those high markups are on the retail line. We need to be involved in that end so that we can cover costs. So we're still kind of brainstorming on how we do that, how we go from providing a basic commodity at anywhere from $0 to we'll match your other guy, and then how do we revenue share off the retail product then? I think we can find a happy ground that's win-win for both in that regard, in terms of that modeling.
Cool. And Julie, anything to add?
Sure. Yeah, this is a lot more, esoteric than what my colleagues have mentioned. But one big thing is when you're really, really small scale and you don't have that ability to prove that you can operate at a massive scale, such as at the economy of scale of fuel, of fossil fuel, is to learn how to connect to your customers' customers. So we are looking to connect to corporations who then are connecting to regular people. And so we've been focusing in on making connections with nonprofits such as the Nature Conservancy, the Ocean Conservancy, as well as ocean cleanup groups in order to collect feedstocks for our reactors from them, while also creating a great social good that is really attractive to people, even though people are not directly our customers.
Yeah. Yeah, a lot around movement building and getting attention. So right now, Kai or Kaj, I probably mispronounced that name, sorry, had a question on customers and market uptake. and wondering if you guys are thinking about commercializing carbon finance into your product, whether it's 45Q in California, other certificates, or any other ways of using kind of the market for carbon right now to help get traction early on.
Yeah, Alex. So I think 45Q, which for those who don't know is a federal program initiated within the last 18 months to provide, I think it's $35 to $50 per ton of qualifying carbon capture and utilization. It was primarily originated, I think, to help the enhanced oil recovery sector, but it has potential benefits for companies like those on the call. The minimum scale, at least for the type of process and product that we do, I believe is 25,000 tons a year before you would get $1 of credit. And so it's not relevant to us at the moment. And I think the program would actually have to be extended in time for it to be relevant for us. It's currently only authorized for a couple of years, I believe. That being said, it's a global world. IndieBio is interested in improving planetary health, and so are we. And so, actually, our first technology license sale is to a Japanese firm, which is under obligation to the Japanese government to reduce carbon emissions by 26% by 2030. In their case, that means a reduction of about 40,000 tons a year of CO2, which should be enough for us to make about 20,000 tons a year of bulk protein product. And so, those kinds of things are certainly interesting. We don't believe that green premium is what's going to drive things in the markets that we operate in. It's going to be the stick probably more than the carrot. And so we're on the lookout for jurisdictions where governments are getting tough on carbon emissions, and that just means that there'll be more resources in those places to support the kind of projects that are of interest to us and that would use our technology.
And Alex, you have anything to add? I know Electroactive there's a lot around food waste as well.
Yeah, I guess similar to like what David said, to qualify for some of these, you have to get to a certain scale. But it's definitely, I would say at the stage that we're at, we are, trying to research and make sure we're aware of all the possible routes out there. I'll talk about a little actually on the hydrogen side with the low carbon fuel standard in California, where our pathway could qualify for credits in there if our hydrogen is used in transportation sectors and a couple other qualifying things. So we think that's definitely a pathway we can go after to get some kind of carbon type credits through our pathway. But one of the things, I guess, to even get to that point is one thing we think we need to do that's really important is to get a kind of third-party verified carbon intensity number for our pathway, which we believe will be a negative carbon pathway. But how much that is and how negative it is, we need to get that kind of number, attached to us so that we can take that to potential customers, investors, and then be able to take advantage of some additional carbon credits that could be out there for sequestering carbon, as well as just being low carbon fuels and negative pathways that can really open it up to us to be able to utilize some of those things to get us to the market faster. So I'd say we're early in the process of figuring out which ones of those we can take advantage of, and so we need to start out with just figuring out, quantifying how negative our pathway is.
And one thing, Alex, and for everyone else as well, I think, in our mind, talking a little bit about do you even if this technology works at the efficiency and scale that you're projecting from early data, or is carbon financing actually something you have to have? I think one of the strong things around these technologies is looking at things that have inherent efficiencies that don't actually require that type of.
Yeah, and I think as of right now, we're not working too much in on the, I would say the LCFS is the only thing we're planning to rely on, because as David said, the other one, the 45Q has, been approved for a few years. The LCFS is a little more stable and seems to be a long-term thing that's going to be there and we could rely on. And so that one we are factoring into some of our costs to be able to get, potentially a few dollars per kilogram credits on renewable hydrogen there. But we certainly want to be able to be not as non-reliant as possible on, legislation or other things to supplement, the revenues that we're getting. We see those things as more of a way to get to the market earlier as we're driving our costs down, but not need them long-term, is where we see as an enabler to get in there quicker. as we're still optimizing, our production and manufacturing.
So I would say the challenge for the innovators is scaling up physically, and as businesses, the challenge for carbon finance is scaling down and making the carbon finance products relevant to innovation, so that we can eventually meet in the middle one day. Yeah, and that's something I think that should really be more deeply considered.
Definitely, yeah. Quincy, Julie, anything you want to jump in on before I move to the next question?
Yeah, happy to share. Thanks for the opportunity.
Okay. Coming in from Kent, I think I'd be curious to hear from each of you guys. What are the current challenges each company and founder is working to overcome to scale product and solution? And now is probably a good time. The audience of AirMiners is a mix of investors, people in big industry, people who are scientists, entrepreneurs. With these challenges, what are the types of things you need help on or you're looking for partners with? So maybe sharing a bit about kind of the place you're at and next milestones for the next couple of years.
Yeah, I'm sorry, or go ahead, Julie.
Okay. Yeah, our big problem is we're taking a technology which is high intensity focused ultrasound that is usually very small. It's used almost exclusively in medical devices, and we're applying it to a technology which is almost exclusively very, very large, which is just large scale chemical reactors. And so in that process, we have to be able to apply this technology, which has never been used in this scale before. Nor has actually using sound in chemistry has been around since about the 70s, but our express purpose of using focused sound is something that's definitely very new. And so since it's a very small community, it's definitely hard to find people who are sort of looking to think outside of the box for what they're applying their current technology to. And we're currently looking for scientific advisors and partners to help us develop our sort of sound side of our technology at scale, because that's something that has never been tried before. Did I answer the question? I hope so.
Yeah, that was great. Thanks. Quincy, do you want to jump in there?
Yeah, so one of our unmet challenges yet, and it's really the big gorilla in the room that we're just keeping to the side, is where are we going to get all this CO2 that we need to in 5 years and sink a megaton of it? That's our goal, 1 megaton out of the atmosphere in 5 years through an array of reactors, and then we move up from that. So for us, it's going to involve location, either being next to a high volume CO2 emitter, an industrial facility, or it's going to be partnering with a direct air capture company, whether it be a Climeworks or a Global Thermostat or some new startup out of Scotland. Who knows what the landscape might be in 5 years? But we will need to have that CO2 source. I mean, we can make carbonates all we want anytime, but it's not negative emissions without the CO2 source. And so putting together a megaton supply annually to start with, at least, isn't really that hard. It's just who's going to do it and who do we partner with, and is this worth us even creating another iteration? Should we get into DAC ourselves? We'd rather not, because we think there's a lot of work to be done just in developing carbonation technology. But finding partners that can produce a megaton of CO2 either from direct air capture, I think is a challenge right now. Hopefully it's not a challenge in 2 to 3 years.
Yeah, I would say one way to think about it is the challenge is not physically the CO2, it's companies that are willing to make the financial and political and other resource commitment to not only make that CO2 available, but to provide all the resources that are necessary to get that CO2 into an innovative process and have it, get the demonstrative results. it's as much about investment and sort of corporate development as it is about, physical access. We've got 40 gigatons a year of CO2 equivalents. So it's not really about the quantities of CO2.
And one thing, if any of you want to jump in on, I know like Dave and Alex, either commercially or through academia, have been around the space for quite a while. If you've seen a change in kind of the appetite for people from that side of the world, the emitters and corporates, to have partnerships and to talk to startups.
Well, I guess I'll jump in real quick, just talk real quick, mention our challenges right now, or that we're, I guess, working to overcome, or as we scale up, or what's, some of the things we're facing there, where at least initially it was, financial in nature to get, enough of team members there to do the kind of work we need to scale up. But luckily we're, have our lead investor on board, but we're still, working to close out the seed round fully. So we're also looking at investors to help push us forward. And since we've gotten, part of the round going and been able to make some hires, we've been making, rapid progress to scale up our system from benchtop to the commercial, or to the pilot level, which we're targeting by early next year. And so for us, some of the challenges of that, that we envision running into once we continue going up is being able to sustain performance and keep it operating for months and years. And some of the ways we're addressing that right now are developing some, a pretty intricate array of sensors and software to analyze and respond to what it's seeing in the system to help us sustain performance, and then developing operating parameters to really kind of control and keep the microbial community stable. And part of our work at Oak Ridge National Lab in developing this technology gave us some fundamental principles to deploy, and we're in the process of executing those in the scale-up process right now. And as far as appetites from other industrial people or carbon emitters, it's depending on the ones you see. I mean, some of the leading ones on the hydrogen side and in our space are oil companies like Shell and other ones that are really seeing there's going to be a transition happening, and they're looking to get ahead of that and be involved with it, and then find decarbonizing pathways to some of those products that have in the past come from petroleum and other things like hydrogen. So some of them are jumping in and seeing that it's going to happen, and it's only a matter of time. And so they're trying to get out in front. And so hopefully that will continue to be the trend, where more companies will continue to jump in and potentially be a partner or a source of funding for companies like ours in the future.
Perfect. At this point, I think I want to thank you, Alex. I'll send it back to you, and then I'll share the links for the next sessions.